Okay, so I'm going to test two steel coupons, a hot rolled and a cold rolled. So this is the hot rolled specimen. It's painted blue on one side and black on the other side. That's how I know that it's hot rolled. It's got black paint on one side of it. So this is the hot rolled specimen. This is the cold rolled specimen. It's painted blue on one end and gray or maybe white on the other end. That's how I know that it's cold rolled, is that it's painted gray on one side. So both specimens are blue on one side, but the black paint indicates that it's hot rolled, and the gray paint or white paint indicates that it's cold rolled. Hot rolled steel, one application of hot rolled steel is the steel rails in railroad tracks. And cold rolled steel, one of the applications is the steel that they use to make appliances. So these are the two specimens that I'm going to test this morning. Okay, so here's the machine, the universal testing machine. I'm stepping back so you can see the whole thing. Okay, so here is the computer, obviously. The computer. I'll be using MTestW software. Let me see if I can find it here. Right here. I'll shortcut to MTestW. Right here. That's the software that I'll be using. So this is the controller. This doesn't belong here. This blue box is the controller. It controls the piston, the hydraulic piston. What do I need a hydraulic piston for? There's a hydraulic piston under here. This is the loading deck. Tinius Olson. This machine was manufactured by Tinius Olson. This is the loading deck. This is the crosshead. This is the top of the frame. So I'll step back, allowing you to see everything. The loading deck on the bottom, the crosshead in the middle, the top of the frame on the top. If I wanted to test something in compression, I'd put it here on the loading deck. So compression testing down here. If I want to test something in tension, I'd put it up here. So I'm going to test the steel coupons in tension, meaning that I'm going to put the coupon up here. So this machine is hydraulically operated, meaning that it uses hydraulic pressure to exert the force on the specimen. These wheels down here, they look like steering wheels. Those are no longer functional, but they used to control the loading and the unloading of the specimen. Now they don't do anything anymore because the machine has been retrofitted to be computer controlled. So the wheels that you see down there are no longer functional. Some of this stuff still works. We don't use the start or stop buttons anymore. The computer takes the place of that. The raise and lower controls the crosshead. The crosshead has an electric motor that allows it to be moved up and down, but we only move it up and down when we're loading the specimen. Once the test starts, we don't want to be moving the crosshead. So there you have it. During the test, the crosshead remains stationary, but it's actually the loading deck that's moving up. So there's a piston underneath here that pushes the loading deck up. It also pushes the top of the frame upward. The crosshead remains stationary during the test, so the specimen, which will be in here, is actually being pulled from the top. So let me step back so you can see this in context. The loading deck on the bottom and the top of the frame up there both move up during the test. The crosshead remains stationary. Okay, over here on the right side, the on-off lever that controls the electric motor. Okay, so let me turn this on, take the padlock off. The sound of electricity. The padlock up here. Okay, so I turned that on. And now I'm going to turn on the controller, so there's a switch on the back side. Switch back here, turn it on. Okay, waiting for Windows, it says. Okay, so now I'm going to fire up the program, mtestw, right here. Okay, and here's the screen that I see. So during this test, it will trace out a load versus position graph. Load versus position, so not really stress strain, but load versus position. It's actually a load versus position of the machine. That is the crosshead, the grips, the frame. And so that's what we'll be looking at during the course of the test. I'll be using an extensometer to measure the elongation of the specimen. This is the extensometer, MTS. Open up the test setup. So let me find that icon. This one right here. Can you see it? Right there. What does that say? Use test setup. Okay, so the first thing I have to do is float the table. So to float the table, I have to click on this, go to 0.5 inch. So that floats the table, meaning that it's going to move the loading deck up a ½ inch, just to introduce some hydraulic fluid into the system. So that's the first thing I have to do. Float the table by going to this selection right here, go to 0.5 inch. But nothing's going to happen until I start the pump. So to turn on the pump, I press the green button here. Okay. Should be moving up now. See it moving up. Once the table has been floated, then I choose this, Civi 302 Lab 1 Tensile Test of Steel with Extensometer. So the hot rolled first. First I'll do the hot rolled. We filming back here? Okay, I just put the specimen in. Now I'm going to put the extensometer on there. How was that? Okay, so I put everything in place. Extensometer is on there. Specimen in place. Okay, can I start this? Okay, so to get this test going, I have to zero it out with this icon. And then press play. You see the diagram being traced out here, load versus position. Well, it looks like I have a little slack there in the specimen. I should have taken that out. It's okay, I'll do it for the next one. Okay, so this is hot rolled, so you see the little hardening plateau being traced out there. When I do the cold rolled, I'll remember to take out that slack. After it peaks, I'm going to take off the extensometer. Here's the specimen. No noticeable change yet. What is the load up to? Reached a maximum yet? No. Here's the entire setup. Maximum yet? Still climbing. Looks like we're up to about 13,000 pounds. How do I know it's the hot roll? Because of that specimen. Not specimen, that plateau. I meant to say that I know that it's hot rolled because the specimen was painted black on one end. But I also know, because I've got the plateau here, the hardening plateau, which took place at 10,000 pounds. See how it zooms out? So nothing really interesting with the specimen yet, I don't think. It might have got, well, I know that it's gotten a little bit longer, but it might not be noticeable with the naked eye. Now once this reaches its peak, then I'm going to pause it and remove the extensometer. Tell me when this starts going down, because when it starts going down, that means it's time to remove the extensometer. I think it's peaked, hasn't it? So I'll let it go a little bit farther. How do I pause it? This button right here. So I think I'm going to do that now. Pause. So I'm going to take off the extensometer. You see the load bleeding off a little bit there when I pause it? Okay, let's resume. Okay, so now we're resuming. And what's going on here? Alrighty then. So once it breaks, I click on F9 to stop it. You see F9? That means stop the test. So it just broke. It just broke. I'm picking it up on the other side with that other camera. So now I'm going to remove it. Are we still filming back here? I'm going to stop this. Okay. So now I'm going to save it. Okay, I just saved it. Now new test. So up here, test, and then new. Okay. New test. Okay, now the cold roll. Okay, so I'm going to put in the cold roll. Actually, you know what I'm going to do? I'm going to float the table again. Actually, I don't need to float the table. I think it's good. I took out the slack this time. I put the potentiometer, extensometer, put the extensometer on here. Okay, extensometer in place. I took out the slack by pressing the lower button a few times very quickly. That takes out the slack, so I won't have that issue this time. Okay, so can we get this started? So zero it out and press play, and there it goes. Filming over here. Back to the main screen. Okay, so here is the specimen with the extensometer on there, and another camera in the back, as you can see. So this time I took out the slack, you see? It just starts there at the 0, 0 position. I don't see the hardening plateau. Why not? Because this is cold rolled. Seems to be kind of sort of leveling out there. So this is the linear elastic portion. So now it looks as though we've done some plastic deformation to this. We have left the linear elastic portion. And once again, I want to pause this and take off the extensometer before it breaks. Now why do I do that? Because when it breaks, I don't want the extensometer falling on the floor. It's an expensive piece of equipment, so I don't want it falling and hitting the frame on the way down, hitting the floor. So that's why I pause it. I pause it after we reach a maximum. So let me know when it peaks and starts dropping, because I want to take off that extensometer. It looks like it already has. Okay, so it has peaked already. Well, so I'm going to pause it. Pause. Take off the extensometer. Bleeds off a little bit. Now resume. Can you see this? Resume. Okay, so now I'm going to step back and wait until it breaks. Okay, let me step back here. Do you see it necking? Is it necking yet? A little bit. Are we throwing over here? What? Okay. Graph looks weird there. F9. Save it. Okay, so now I'm going to shut this off. Actually, let me remove the specimen first. So removal of the specimen. I'm going to shut this camera off. Okay, so when I close the program, then the hydraulic pump turns off, so that's why you don't hear the sound anymore. I'm going to turn off the controller. So the switch is around the back side, right here. I don't like to hear that buzzing sound of the electricity, so I'm going to turn off the electricity over here. Like that. So there it is. The hot rolled and the cold rolled specimens. Okay, so it's Saturday morning, Saturday, January 16th, 9:44 a.m. I just completed the tensile test of steel. So which is this? Is this the hot rolled or the cold rolled? So I broke the specimen. Do you think super glue would put these back together again adequately? So there you have it. That's the cold rolled specimen. The hot rolled specimen. Here's the hot rolled specimen. All right, so there you have it, the tensile test of steel.